Tapos na. Hands ako. Lahit sa mga daig mo. Matsagay itong sana.
They know a lot about Pakistan. CE1L.
Good day to each and everyone watching CE1L. Today we are going to talk about the volume of solid of revolution and its application. So what is solid of revolution? It is a solid figure obtained by rotating the plane curve around some straight line that lies on the same plane. What are its application in real world? Its application in real world, if we could find a general method of calculating the volume of solid of revolution, then we would be able to calculate, for example, the volume of a sphere and the volume of a cone, as well as the volume of a more complex solid. These are used commonly in engineering and manufacturing, such as axle, funnels, pills, bottles, and pistons. How we can solve this? This type of solid will made up of one of these type of elements, such as disc, washer, and cylindrical, each of which requires different approach in setting up definite integrals to determine the volume.
When dealing with volume of solids of revolution, if the axis of revolution is a boundary of plane region and the cross sections are taken perpendicular to the axis of revolution, then we will use the disk method to find the volume of the solid. If a disk is perpendicular to the x-axis, then its radius should be expressed as a function of x. If a disk is perpendicular to the y-axis, then its radius should be expressed as a function of y. Speaking of volume, the volume of a solid is generated by revolving the region bounded by y equal to the function of x, and the x-axis on the interval a to b about the x-axis is this. And if the region bounded by x equal to the function of y and the y-axis on a to b is revolved about the y-axis, then its volume can be calculated using this formula. For example, find the volume of the solid obtained by revolving the region under the graph of y equal to the square root of x on interval 0 to 2 about the x-axis. So referring to the figure, region R given by y equal to square root of x is being rotated about x-axis, and we get resulting solid shape like this. Cross-section is shown with green sliced disc, which is perpendicular to axis of rotation, which is the x-axis, having width dx. So the approximation rectangle having width moved from 0 to 2 in x-axis. Since the axis of rotation is in x-axis, we will use the formula volume equal to integral from a to b of pi times function of x squared dx. And by applying the values into the volume formula, we get the volume equal to the integral from 0 to 2 of pi times square root of x squared dx. By evaluating it, we will come up with an answer of 2 pi cubic units. So that is how the disk method works.
The washer method. Now, when and where should we apply the washer method? According to the definition, in using the washer method, there needs to be two boundaries in the plane, which is the upper boundary and the lower boundary, intersecting with one another. These boundaries are functions. The volume of the area between these two boundaries can be found by the formula volume is equals to times the integration from a to b of function 1 minus function 2 dx or dy, depending on the axis of rotation. Now for an example, an area bounded between the function of x squared and the function of x cubed in the first quadrant revolved around x-axis. We first graph the two given functions, which is x squared and x cubed. Now, as you can see, In the quadrant 1, the two lines are intersecting at the points 0 and 1 at the x-axis. Now we need to find the volume between these two functions. Since the rotation is on x-axis, we need to use the formula of where the x-axis is rotating. Volume is equals to pi times the integration from 0 to 1 of the squared of x squared minus the squared of x cubed dx. Now let's simplify this. Volume is equals to pi times the integration from 0 to 1 of x to the power of 4 minus x to the power of 6. So, we integrate x to the power of 4, which is x to the power of 5 over 5. And x to the power of 6 is x to the power of 7 over 7. Since this is a definite integral, let's continue by replacing the x variables with the limits from 0 to 1. So the final answer for the volume between the functions x squared and x cubed is this. The volume is equals to 2 pi over 35.
Cylindrical method. So, what is cylindrical method? Cylindrical method is another way to calculate volumes of revolution. This is useful whenever the washer method is too difficult to carry out, usually because the inner and outer radii of the washer are awkward to express. So, there are two types of formula in cylindrical method. If rotation is in the y-axis, our formula is v equals to 2 pi times integration from a to b of xy dx. If rotation is in the x-axis, our solution is v equals to 2 pi times integration from c to d of xy dy. And now we have an example problem to solve. So our example problem is to determine the volume of solid obtained by rotating the region bounded by y equals to x minus 1 times x minus 3 to the power of 2, and the x-axis about the y-axis. In solving the problem, let's first graph the bounded region and the solid. Note that the bounded region here is shaded portion shown. The curve is extended out a little past this for the purposes of illustrating what the curve looks like. So, we basically got something that's roughly donut shape. If we were to use rings on this solid, here is what a typical ring would look like. Last problem with rings is the case is not so much a problem as it's just added work. If we were to use rings, the limit would be the y limits, and this means that we will need to know how high the graph goes. To this point, the limits of integration have always been intersection points that were fairly easy to find. However, in this case, the highest point is not the intersection point, but instead a relative maximum. We spent several sections in the applications of derivatives chapter talking about how to find the maximum values of functions. However, finding them can on occasion take some work. What we need to do is to find a different way to cut the solid that will give us a cross-sectional area that we can work with. One way to do is to think of our solid as a lump cookie dough, and instead of cutting it perpendicular to the axis of rotation, we could instead center a cylindrical cookie cutter on the axis of rotation and push this down into the solid. Doing this would give the following picture. Doing this gives us a cylinder or shell in the object, and we can easily find its surface area. And then we will solve our volume with this formula. V equals to 2 pi times the integration from a to b of xy dx. We will use this formula because it rotates to the y-axis. Then simply substitute our value in ax to the xy. Then we will get 2 pi times x to the power of 4 plus 1 over 4 plus 1 minus 7x to the power of 3 plus 1 over 3 plus 1 plus 15x to the power of 2 plus 1 over 2 plus 1 minus 9x 1 plus 1 over 1 plus 1 from limit 1 to 3 plus c. And then simplify and we will get this. And then we will use our limits to substitute to the x. And limit 3 will be subtracted by limit 1 and the answer will be, and by simplifying that we will get this. And the final answer is 24 over 5 pi cubic units.
in summary, to get the disk method, if the axis of revolution is the boundary of the plane region and the cross sections are taken perpendicular to the axis of revolution, then you can get the volume of the solid. So if I use this formula for the x-axis and I use this formula for the y-axis, I can get the volume of the disk method. So in the washer method, if the axis of revolution is not a boundary of the plane region and the cross sections are taken perpendicular to the axis of revolution, you use the washer method to find the volume of the solid. Moreover, if a washer is perpendicular to the axis, then the inner and outer radii should be expressed as function of x. If a washer is perpendicular to the y-axis, then the radii should be expressed as a function of y. So meaning I should use this for the x-axis and I should use this formula for the y-axis to get the volume. Okay? Go here. Cylindrical shell method. If the cross-section of the solid are taken parallel to the axis of revolution, the cylindrical shell method will be used to find the volume of the solid. It is worth noting that if the axis of revolution is vertical, then the radius and height should be expressed in terms of x. If the axis of revolution is horizontal, then the radius and height should be expressed in terms of y. So if the revolution is vertical, then it should be expressed in x. Then if it is horizontal, it should be expressed in y. Ay, salamat naman na jud ko makadula ako.